Hello and welcome to Prescriptive Analytics. We are in the first problem in integer linear programming, and we are going to talk about employee scheduling. These are workforce scheduling problems, and we are going to use this as an example to show how we can use integer constraints in Excel. My name is Hari Rajagopalan, and I will be walking you through this lecture. So let's take an example of a company called Air Express. This is a shipping company, and it guarantees overnight delivery packages anywhere in the United States. The company has various operation centers, which it calls hubs at airports and major cities. Packages are received at hubs from other locations, then shipped to intermediate hubs or final destination. And the manager in the Baltimore hub is concerned about labor costs and wants to determine the most effective way to schedule workers. Hub operates 7 days a week. Number of packages it handles each day varies from one day to next. So they use a historical data on the average number of packages received each day. The manager estimates the number of workers needed to handle the package as shown in this table here. So on Sunday, he says he needs at least 18, Monday is 27, Tuesday is 22, and so on. Now, the package handlers working for Air Express are unionized, a guaranteed 5-day work week with 2 consecutive days off. Base salary is $655 per week. Because most week workers prefer to have Saturdays and Sundays off, university has negotiated bonuses of $25 per day for its members who work on the day. So if you're working Saturday and Sunday, it's $50 more, right? So you have different shifts 1 to 7. And so if you work Sunday and if your days off are Sunday and Monday, your wage is $680, Monday and Tuesday is $705, Tuesday and Wednesday is $705, and so on. It's already given to you. So the manager wants to keep the total wage expense of the hub as low as possible, and with this in mind, how many package handlers should be assigned to each shift if the manager wants to have sufficient number of workers available each day. So let's think about this problem. Again, here the key is going to be how you define your variable. And your variable definition becomes critical, and this is where a lot of you go wrong. So if you think about this problem, the objective is to minimize your total cost, right? So you need to figure out, you have days of the week, Sunday, Monday, and the number of workers needed. And then here you have shift 1, right? So if I focus on shift 1, then your Sunday and Mondays are off. This worker starts from Tuesday all the way till Saturday, right? Then shift 2, he'll be working on Sunday. Monday and Tuesday are off, and Wednesday till Sunday, right? And so on. That's pretty much how you're looking at it, right? So if Xi is the number of workers to work in shift I is 1 to 6, that should take care of your decision variable. You can't use your days. Days actually are your constraints, okay? So here's what we've got. 7 shifts, okay? So your decision variables are x1 to x7. So remember that x1 is essentially, if you're in shift 1, you will start work on Tuesday. If you're in shift 2, you start work on Wednesday. Shift 3, start work on Thursday. Shift 4, start work on Friday. Shift 5, start work on Saturday. Shift 6, start work on Sunday, and so on. So now you can minimize the cost for each shift, right? If you're in first shift, so many workers, $680 per worker. Now you're going to subject to workers required each day. If you're in shift 1, right? If you're, sorry, Sunday, if you look at Sunday, shift 1, let's go back here. Sunday, shift 1 and shift 7 don't work on Sunday. So you have 0 times x1. There is no x1, there's no x7. So it's x2 to x6. On Monday, it'll be x3 to x7. Tuesday, it'll be x4, x5, x6, and x7, and so on. So this is the worker required for each day. And you're going to say xi is greater than 0 and integer for all I. So let's look at how we're going to set it up in Excel. All right, let's look at this. And before we do that, just wanted to show you this visual here, which actually shows you shift 1, start on Tuesday to Saturday, shift 2, Wednesday to Sunday, shift 3, Thursday, and so on. So you can kind of see, visualize this problem. So let's stop here and let's go to Excel, and I'm going to show you it's setting up as the same thing, except now we're going to actually insert the integer constraint. So as you see here, here's the visual view, and here is the model. And like all models, you are going to put x1 to x7, essentially leave the first row blank, objective coefficient, sum product here. So these are all in dollars, so let's go ahead and convert that into currency. And we get that. And you're going to plug in your constraints. Now this is greater than this. So if you go to Analytics Solver, that's also set. And you're also going to ensure that these are integer constraints, right? And once you solve it, you get the answer, which remains says that shift 1, you need 5 people, 6 people in shift 3, 8 people in shift 5, 4 in shift 6, 10 in shift 7, and that'll cost you about $22,540, which is the minimum.